Polygons are shapes with many corners. Poly meaning many, gons, corner in Greek. Some people might say polygon's a dead parrot, but hey. So they always have straight lines, and the lines always join up. So our polygon has no curves. Okay, and the simplest, most basic polygon is made with 3 lines as a triangle. Okay, so within the family of triangles we have equilateral triangles up here, and these ones have all 3 sides the same, AAA, and that means that the corners or the angles are also all the same as well. Okay, so the slope of these angles here. Next we have the isosceles triangle, and instead of all 3 being the same like the equilateral, we have 2 the same and the 1 different. So it could be tall and skinny, but it also could be that B is the longer edge, so it could be that B is long and skinny, and then A are little short ones like that, like a squashed hill, if you like. Next type of triangle is very important in construction and engineering because it forms corners in buildings and walls, is our right angle triangle, and that corner there, or that angle, is 90 degrees. Okay, so that's how we measure angles in degrees, and that's what we call a quarter turn or a quarter of a circle, because if we went 4 times round, that many angles would have a full circle at 360 degrees. Next one down here is a scalene. And a scalene triangle is characterized by the fact that none of the angles are the same as each other and none of the lengths are. Okay, now that could be the case for right angle triangle, but what makes the right angle triangle special is that right angle, and that has a whole lot of maths associated with it. Next basic types of shapes, we'll just talk about the 4-sided shapes. A lot of people would say the quadrilaterals. So the quadrilateral is the family name for the 4-sided shapes, and the common ones that most people are aware of would be the square, the rectangle. But here we have a trapezium or trapezoid. We call them trapeziums in New Zealand more than anything, and a parallelogram here. And a special parallelogram where all the sides are the same is called a rhombus, so that's a type of parallelogram. And over here we have a kite. So if I was to spin that around, we would see that it looks like a flying kite. Okay, and that's characterized by the fact that we have 2 edges here, or 2 lines that are congruent, same size, and these 2 up here are also congruent with each other. Now if we also folded that in the middle, so if we put a fold line through there, it would reflect, and that's quite important. So when I draw a line from one corner to the other and there to there, those lines would be called bisectors because they bisect the opposite angles. Moving right along, now quadrilaterals are very important, and you need to know quite a little bit more about them to know that. How do you know which one you're talking about? And we'll look at the properties of those. So what we'll need to do is understand the language of the properties up here, so we'll go through those words in a minute. Meanwhile, just to alert you to the fact that apart from triangles and quadrilaterals, we then, depending on the number of sides, have other polygons, and they're labelled pentagon, hexagon. So pen there means 5, hexagon, hexi is 6-sided, heptagon 7 like a heptathlon, octagon like an octopus, or October was meant to be the 8th month, but they threw a couple more months in there. Alright, so that's 8 sides, actually that's there. And nonagon, 9, and decagon. So those also have special properties associated with them too that we'll learn about. Next, we have these ideas here. So the first one is how, let's do the lines meeting first. So how lines meet. So when you've got 2 lines, such as even 2 lines in a shape like that, the edges, sometimes edges don't meet when they're opposite. Let's look at opposite and adjacent first, okay? So opposite edges are across from each other, and if we'll just look at one example here, so side 1 and 4 are kind of opposite. 1 and 4 here certainly are, and 5 and 2 are opposite, and 6 and 3. So that line and that line are opposites, and the other compared with, where has it gone? Adjacent lines. So adjacent lines are next door to each other and they touch. So over here 1 and 2 would be adjacent, and 3 is also adjacent to 2 because they touch together and they meet. So those lines there, the way that they meet is called an intersection. So how lines meet, if they cross over and meet at a point or end at the same point, this is called a vertex, a corner, they're intersecting lines. When they intersect at right angles, so they're perfectly perpendicular, we call that, and that's a very important property because of course we've got our squares. And so we use the word perpendicular to describe 90-degree angles, and of course we had our triangle as well, and our right angle triangle, so those two black lines there are perpendicular. Okay. And the other one is our parallel lines, our train tracks, and usually opposite edges on a polygon may have parallel properties. So we can look at the shapes that have those. Next, we look at the position of objects. If this line here that I'm just drawing with a cursor is a horizontal line because it goes sideways, okay, and a line that goes straight up and down is a vertical line. These words are important to understand, so you might want to come back to the notes here or the this video, or I'm going to leave you a picture of this so that you can understand, because we need to classify polygons next, and that means we need to define them or give some qualities or properties of them, and you need to be able to say what type it is. So in college maths, you never get told, here is a kite. You get told, there is a shape with two adjacent edges that are the same length, and the opposite two are the same length. It's a quadrilateral. Opposite angles are congruent, but the other pair of opposite angles are not. That actually describes a kite. So you're going to get all this jargon that you need to define what the properties are. Now that's all.